Now for the last part, part C, we're given that the position vector of the particle P is minus 4i plus j meters when t is 1. And we've got to find out then the position vector of P when t equals 4. So how do we do this? Well, normally we would find velocity as dr by dt. But if we're working backwards to get the position vector in general, then we have to integrate velocity with respect to time. And this is our starting point. We know that the position vector in general is given by the integral of velocity with respect to time. So we just need to put the velocity vector in, which we know is 2t I minus 3t squared j. Okay, we got that, and then integrate that with respect to time, dt there. And in the usual way, if we just integrate each of these two terms, add 1 to the power and divide by it, we end up with the first one being 2t squared over 2, which is just simply t squared in the I direction. And for this one, we've got to add 1 to the power, that's t cubed over 3, and the 3's will cancel, so you'll end up with minus t cubed in the j direction. And what we mustn't forget is the constant of integration, plus c. But it is a vector constant, okay, so let's just put a squiggle underneath there. Now we've got to work out what this constant is, and so we need some condition that we know is true. And that is this condition up here. Let's just call it 1, okay? We know that when t is 1, the position vector r is minus 4i plus j. So if we use that, we can say that from 1, okay, if we substitute for r, we've got minus 4i plus j, let's just put it here, minus 4i plus j. That's going to equal the result we get when we put t equals 1 into here. So we've got 1i minus 1j. In other words, we've got I minus j, and then plus that constant c. So we can get what c is, therefore c equals, if we just take I from both sides and add j to both sides. So taking I from both sides gives us minus 5i, and then adding j to both sides gives us plus 2j. So there's our constant c, and then if we substitute this back into this equation here, we therefore have that in general r is equal to t squared I minus that 5i as well, so we could write that as t squared minus 5 in the I direction. And when it comes to the j components, I've got minus t cubed in the j direction and 2 also in the j direction. So I've got plus 2 minus t cubed in the j direction. Okay? So we had to find out the position vector of the particle P when t equaled 4. So all I need to do is just substitute that value of 4 into here for t. So when t equals 4, what do we end up with for r? R equals, well, we've got here 4 4s are 16 minus 5, so that's going to be 11. 11i, and when we put 4 in here, we've got 2 minus, what's that going to be? 2 minus 64, so it's going to give us minus 62, minus 62j. Okay, and let's just put brackets around that and write the meters there. Okay, so general position vector is here, but at time t equals 4, it's at this point. Okay, that brings us now to the end of this question.